Hello and welcome back to Precalculus. Section 5.2 on sum and difference formulas. This is for trigonometry. So we're going to take a look at what happens when you have sine and cosine and then eventually tangent and so on of two angles. So the formulas that we are trying to memorize here, and you really need to learn these formulas because they will lead into other things later. So sine of x plus y, sine of x minus y, cosine of x plus y, and cosine of x minus y. So we have these four different formulas. They are all similar, but that's what they look like. And x and y are two angles. They could be the same angle, right? Which we will see in the next section, what happens when it's x plus x rather than x plus y. But now, let's just take a look at sine of x plus y. Okay, so sine of x plus y is sine of x cosine of y and then plus cosine of x sine of y. So this is the formula, and the sine x goes the same, sine of x minus y goes the same way, except it has a minus. There we go. So those are the two sine formulas. Very easy to remember because you go sine x cosine y, you keep the same sign, and then cosine of the other one, right? You had a sine of x, now you have a cosine of x. And then sine of y. And then when it's minus, you just have a minus there. Now, cosine, some argue this is actually easier, but whatever. Cosine x cosine y, but you have to change the sign and have sine x sine y. And the same for the bottom formula. Cosine x cosine y plus sine x sine y. So, usually confusion is with these. Now, these formulas are very useful because we can find values of sines and cosines of certain trig, of certain angles that are not in that table that I gave you for 30, 45, and 60 and 90, right? So what if you have 15 degrees, right? Can you deal with 15 degrees somehow? Can you compute the sine of 15 degrees? Well, now you can, because you have these formulas. These formulas are great to find those types of angles. Obviously, you still can't compute sine of 3 degrees or 1, but these formulas are going to help you figure out more angles than you had before, which is why they're useful. So let's take a look at sine of 15 degrees. So how much is that? Well, obviously, I mean, if you type this thing in a calculator, you're going to go get those dumb decimals. But if we want the exact value in terms of square roots and all that kind of stuff, no decimals, we can use these formulas to help us figure that out. As soon as you figure out that sine 15 degrees is sine 45 degrees minus sine 30 degrees, because you can create 15 when you subtract 30 from 45. Awesome. And now, unleash the formula right here. Unleash the formula. And as you can see, all of your calculations will be done on 45 and 30. And you know those values because you learned them, right? from that chart. So, actually, this is an example, so we don't have to be dramatic. There we go. So that's going to be sine 45 degrees, cosine 30 degrees, keep the same sign, and then cosine 45 degrees, sine 30 degrees. And now all we need to do is to populate these values. Sine of 45 degrees is root 2 over 2. Cosine of 30 degrees is root 3 over 2. Minus cosine of 45 degrees is root 2 over 2. And sine of 30 degrees is 1/2. You can see that you have the common denominator of 4, because 2 times 2, right, on both. And you just have root 6 minus root 2. That is exact value. Yes, you can get decimals. No one cares about it, but you can get decimals. Let's see. Get cosine of 7 pi over 12 using 7 pi over 12 is pi over 3 plus pi over 4. Not a problem, I hope. Cosine of pi over 3 plus pi over 4 is cosine of both. Change the sign. Sine of both. That's how I memorized these as a student. When I learned this, I don't know, back in the 10th grade, I think. I remembered as cosine of both, change the sign, sine of both. I don't know, that just worked for me. But because I'm a visual learner, both, they're the same, right? Both as x and a y, and then these signs are opposite, so change the sign, keep the sign. For some reason, those things get stuck in my head, and I just use them, right, as I do the formulas. Even now, I mean, I've been shoveling this stuff for 15 years or whatever. I mean, teaching for 10 and then whatever. It's just still, I still use the same tricks. Cosine of pi over 3, 1/2. Cosine of pi over 4, root 2 over 2. Now you might say, how do you know? I learned it. So you sit and you learn. Yes, invest time and go through the values over and over and over again. And when you drill, like anything else in life, right, you spend time, invest time and energy, blood, sweat, and tears, and there you go. You will know the values as well. So root 2 minus root 6 over 4. Nice. I'm just going to jump. By the way, that's it. That's what we have in the section. They do give you also tangent formulas. No one memorizes these, unfortunately. Maybe not unfortunately. They're not used. I mean, when they pop up once in 4 courses of math, you can look them up. Tangent of x plus y is tangent x plus tangent y divided by 1 minus tangent x tangent y. And tangent x minus y is tangent x minus tangent y divided by 1 plus tangent x tangent y. You can see that both of these formulas are the same. It's just you keep the sign in the numerator and you change the sign in the denominator in comparison to your original sign, right? Let's see what types of problems homework brings. All right, so these are now the problems that tend to be just annoying because it's just a lot of work to solve them. So this is what you're given in problem 18, and you're supposed to find the exact value computing this. So what do? Well, you know the formula, which would be cosine 240, cosine 45, change the sign because it's cosine there, and then sine 240 degrees, and then sine 45 degrees. So we know that. Yay, right? But now you have to compute cosine 240. This is where the reference angles kick in, right? So how much is cosine 240? This is why I say we're getting into, annoying problems. It's not difficult. You just have to jump through hoops, right? Jump through the hoop to get the formula down, and then jump through hoop to calculate sine and cosine of 240. Okay, so where is the 240? Well, we know that this is 270, and this is 180, right? So 240 is 60 degrees after 280, so it's right there. So that's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. I just love my reference angles to be in radian measure, but in our case, 240 minus 180 is 60 degrees, and that's the reference angle R. All students take calculus, cosine is negative, so negative cosine of 60 degrees, cosine 45 degrees, minus sine is also negative in that one, so negative sine of 60 degrees times sine of 45 degrees. Negative 1/2 root 2 over 2 plus root 3 over 2 and root 2 over 2. So that's root 6 minus root 2 over 4. That's another problem that has the same values shoveled around. It's not all the problems have that answer. We had 3 with the combinations of those. Okay. So I will give you a problem to try. Well, I think this was an exam problem at one point, so give me my problem 20. Cosine, compute cosine of 105 degrees. And then the student put decimal answer and put the 0 on it. So, yeah, find the exact value with square roots and all of that stuff. And, yeah, let's see how it goes. What are the two angles that you guys are using? Anyone? The ominous silence. It's supposed to be an easy question.
60 and 45.
Thank you. Perfect. Yes. So 60 and 45, those are the two angles that we use. And then we just write out the formula and have the values computed quickly. So cosine of what do we have? 60 and 45. And then we expand that with our formula. So cosine of 6, come on, pen. There we go. 60 plus 45 degrees. That's going to be cosine 60, cosine 45. Change the sign, and then sine 60, and then sine 45. Cosine of 60 is 1/2. Oh, this is going to be the same, same answers. Sine of 60 is root 3 over 2. And sine 45, root 2 over 2. So root 2 minus root 6 over 4 again. Again! All right, so now I also said that we can solve identities with this, right? Because ultimately, these are trigonometric identities, left side equal to right side. And we can figure out some of those. So let's take a look at what they have over here. They want you to prove that cosine of alpha plus beta, those are A and B in Greek. So cosine of alpha plus beta times cosine of alpha minus beta is equal to cosine squared beta minus sine squared alpha. Well, that should not be an issue if you replace the left side with the formulas we just learned and just grind through algebra. So let's see if you can get through that stuff. Okay, let's take a look at this problem together. Again, it's just traveling algebra. So we replace cosine with cosine alpha, cosine beta, minus sine alpha, sine beta, times cosine alpha, cosine beta, plus sine alpha, sine beta. And we are supposed to multiply this, but again, depending on your algebra, you have a minus b, a plus b situation here, because this term is the same as that term, and then the sign terms are the same, and just one is minus, one is plus. So we can write this as cosine alpha, cosine beta squared minus sine alpha, sine beta. Squared. So cosine alpha cosine beta minus sine alpha sine beta times cosine alpha cosine beta plus sine alpha sine beta. This and this is the same, so it gets there to be plus. This and this is the same, so it goes there, it's a minus. So now, okay, so that's the first step. And now we're supposed to see, right, what we have for the next step. So um, we can combine this. No, we can't. Cosine beta, alpha sine beta. I can't factor. Okay, do we transform now the other side? The other side. So I think we're stuck on the left for now, because nothing factors. We can write this as cosine squared alpha cosine squared beta minus sine squared alpha sine squared beta, but we still can't factor anything, so we didn't achieve, I don't think, we don't achieve anything, right? Yeah, I don't think we achieved anything there. So on the right hand side, what can we do for the right hand side? I can change the cosine beta into 1 minus sine squared beta, and I can change sine squared alpha into 1 minus cosine squared alpha. Now, did that help at all? Well, I don't need these parentheses, first of all. And this would be a plus. And yeah, we got to the same where we started, right? Because when I cancel the ones, okay, that's not the way. Okay, so this is now where we are stuck. I am stuck until I figure out something. So now, when I look what I need, which is this, I need to get rid of the cosine squared alpha. Now, the way to get rid of it is either by factoring or by division. Now, we can divide. Let's factor out and see. Now, you're going to say, well, we don't have it in this term. I know. Let's see what we get. So if I factor out cosine squared alpha, because I want to get rid of it, and this stays as a cosine squared beta, minus, since I didn't have this term in the second parenthesis, I will just get that over cosine squared alpha, like this. Now, what did I achieve? I have cosine squared alpha, cosine squared beta, minus, and now this is tangent squared alpha, sine squared beta. I did not achieve anything in this case. Move this one to the other side. It becomes a secant. And then 1 minus tangent. I think, yeah, but I can't factor this. It's so close. Maybe multiplying both sides by something. Is there a better way? Now we use the formulas we were supposed to use. This is where the stuff becomes interesting to me, when it's not obvious, and you have to look around. Like all of the other problems were a joke. This one is very interesting because it's so close, but it's not there. You can see 1 minus tangent squared, right? Alpha, and then if this goes to the other side, it will go as a division. So 1 over that is going to be a secant squared alpha, and that's the identity, right, for both sides. But we can't really free it up that way. I still need to see what is the actual way over here to get through all of this stuff. So let's go back. Cosine, 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 and they multiply into a square, and minus, and then sine alpha, sine beta square, and the cross terms cancel because it's a minus ba plus b. Now that is somehow equal to cosine squared beta minus sine squared alpha. I'll find it eventually. So if I apply the squares, distribute the squares, we get the cosine squared alpha, cosine squared beta. If anyone sees the solution, you are welcome to chip in, obviously. Otherwise, I'm just going to have all the fun on my own. Cosine squared beta minus sine squared alpha. So they don't have anything in common. If I factor out cosine squared alpha to leave the beta, I do get that tangent inside. Tangent can be written, let's try that, I didn't try that yet. Cosine squared beta minus. Now, tangent can be written as 1 minus secant squared alpha times sine squared beta. And that, I think, just makes everything worse. Yeah, it makes everything worse. I don't think that's the way. So we'll get rid of it. What is the trick here? What would be the trick to solve this problem? You know what? When you get stuck, write it again. Cosine alpha plus beta. Cosine alpha minus beta should be equal to cosine squared beta minus sine squared alpha. Now, I'm not allowed to use any other identities than the basic one we learned. So again, cosine alpha cosine beta minus sine alpha sine beta, cosine alpha cosine beta plus sine alpha sine beta. And then if we do the a minus b times a plus b, because that's what we have, it would be a squared minus b squared. Yep, everything that I had is still the same. So cosine alpha cosine beta, everything squared, minus sine alpha sine beta squared. Only 4 minutes. I gotta I gotta figure this out. I want to figure this out. Uh, hmm. So I tried factoring cosine alpha because that was something that I didn't like. Cosine squared alpha cosine squared beta minus sine squared alpha sine squared beta. Yeah, I have no clue. At this point, I'm so stuck. If it's something simple that I'm not seeing, I'll cry later. but I am completely stuck. It looks so simple and obvious, but it's not. So factoring cosine alpha didn't work. Same thing would happen if I factor out sine beta. I'll just have a tangent over there. I mean cotangent. Cosine over sine. So that didn't work. Now, if you write the other side expanded, it will be cosine beta minus cosine alpha, and then cosine beta plus sine alpha, like this. Does that help? Because that's a squared minus b squared, right, on this side. And I have cosine beta minus sine alpha, cosine beta plus sine alpha. And okay, that didn't help either. All right, the last resort, and then if I don't get it now, I'll have to meditate on this and bring it back next class. Obviously, hopefully you guys will also try and do the same. The last straw is for me to add this term to the other side and see if that's going to do anything. Fingers crossed, right? So on the left now we have cosine squared alpha, cosine squared beta, and on the right I have cosine squared beta minus sine squared alpha plus sine squared alpha sine squared beta. Ooh, I can factor now there. Cosine squared alpha cosine squared beta. So I can factor, let's say, sine. I can factor sine. So cosine squared beta. And now if I say plus sine squared alpha, in parentheses, I will have sine squared beta minus 1. Right? I think so. Sine squared beta, because I'm factoring positive 1. Now if I factor a negative, then this term, so okay, if I factor out a negative, then I get 1 minus sine squared beta. And that's a cosine. I think this is it. Hold on a second. So cosine squared beta minus sine squared alpha, and this thing is now cosine squared beta. And now I can factor out cosine squared beta, sine squared alpha, cosine squared beta. Over here I can factor out cosine squared beta, and you get 1 minus sine squared alpha, and that is cosine squared. There you go. See? Never give up. Even when you are stuck and when all hopes are done and nothing works, eventually it has to work. Wow, that took much longer than I anticipated, but I got it. What was the trick? The trick was to add this term on the other side and then do some algebra factoring. Okay, and that worked. So the key was once I added this term, I see that both of these terms now have sine squared alpha, which is exactly what I factored over here. And there you go. That was it. Once I got this term out, then 1 minus sine squared became cosine squared, gave us this line here. From there, cosine and cosine were the ones that I factored here. And then this gave us that. Left side equals right side. That's all we needed. Done deal. Problem solved. Never give up. Never give up. All right. Well, that's it for today. I will see you in 2 days. Bye.